Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, learn about what astronomers have to say about life, and find out what's going on up above your head, all in the same place. So, we hope that you join us every second and fourth Tuesday of the month at 6 p.m. Mountain Time on Facebook, Twitch, and YouTube. We'd love to hear from you, so you can chat your messages to us on YouTube and Twitch, and we will respond to those when we receive them. On tonight's show, we have PhD student Sonalika Purkayastha from the National Center for Radio Astrophysics at the Tata Institute of Fundamental Research. Among other things, Sonalika studies neutral hydrogen gas in green P galaxies, and we will hear all about that later this evening. But before that happens, let's welcome tonight's co-star. Tonight we have journalist and founder of the Space Tourism Guide, Valerie Steineck.
Hello, glad to be back.
Yeah, glad to have you, Valerie. It's good to have you. And our special guest for this evening, Sonalika Purkayastha.
Hi, it's
Hello.
very nice to be here.
Yeah, so wonderful to have you. All right, everybody, we are going to get started on Astro Advice, the first segment of our show. And so I will read you the quotation, and then you'll get to guess which of the four possible quoters actually said the quote. So the quotation for tonight is: the more clearly we can focus our attention on the wonders and realities of the universe about us, the less taste we shall have for destruction. So that's a quotation, and your four possibilities are Elizabeth Blackwell, Rachel Carson, Grace Hopper, and Cecilia Payne-Gaposchkin. Elizabeth Blackwell was a British and American physician who was the first woman to receive a medical degree in the United States and the first woman on the medical register of the General Medical Council for the United Kingdom. Rachel Carson, of course, the American marine biologist and conservationist, most well known for her influential book Silent Spring, which really started the environmentalist movement. C. Grace Hopper, American computer scientist and mathematician, United States Navy Rear Admiral, one of the first programmers of the Harvard Mark I computer, and she was a pioneer in computing programming, who invented one of the first linkers, which is basically one of the first ways to have multiple different programs linked together. And finally, Cecilia Payne-Gaposchkin, a British-born American astronomer and astrophysicist, who was the first to propose in 1925 as part of her PhD dissertation that stars were primarily composed of hydrogen and helium. At the time, the standard model was that stars were composed of the same stuff as the Earth, which was wrong. And actually, her thesis advisor tried to convince her not to publish it because it was so outlandish. And he later stole her idea. So there you have it. So those are your four possibilities. And I'll bring them all up again. And so, Valerie, what do you think? Which four of these notable scientists said this quotation?
So I feel like I'm on Who Wants to Be a Millionaire and I can rule a few out right away. primarily because there's some phrasing in here that is distinctly British to me. So I'm gonna let's go with Elizabeth Blackwell just to make a commitment to one of them.
Okay, so one vote for Elizabeth Blackwell. Sonalika, what do you think?
This sounds like a quote that would come from a conservationist. So I am going to go for Rachel Carson.
Okay, so one vote for Rachel Carson. The correct answer is Rachel Carson. Sonalika, nicely done. That is 1 point for you. So, what do you think about this quotation? This one's a little bit different than what we've done in past shows. What are your thoughts?
I really like this quote because I think we, as people who are interested in astronomy, perhaps now knowing who spoke the quote, it reframes it a little bit. So we think about the universe as this huge, all-encompassing concept that we're trying to learn more about. And I think, maybe in some ways, Ms. Carson just meant that if we just have more appreciation for how incredible even our planet is, we have less of a desire to do any destruction to it. Though, of course, the more we know about the entire universe, we have that same reaction of how special our planet is.
Yeah, I couldn't agree more. The phrase that came to mind for me was one that I've used in presentations before, which was finding the extraordinary in the ordinary. Right? Recognizing all the amazing things of everything just around us and out in the cosmos as well. So, Moika, do you have any thoughts about this?
I absolutely agree with what both of you said. And I think like an important word for me in the quote is wonder. And I think like a lot of time we tend to see the world from a utilitarian point of view where we kind of try to think of what we can extract for it. And I think wonder is a very good counter for that. And yeah, it's like beautiful lesson.
Oh, I really love that. I never thought about wonder as a countermeasure for utilitarianism, but that is great. I really, really like that. Yeah, and it is, right? You see things for like their inherent value as opposed to what they might be able to give you or do for something or do for somebody else. That's lovely. Thanks for making that connection. Any other thoughts on this? I think she's right, and but I'm not totally sure that it's only wonder for the realities of the universe that is necessary. I feel like there's more. I feel like you also need to have some analytic understanding of what it is that you're looking at in order to completely lose your taste for destruction. I wish wonder was enough all by itself, but I actually feel like there's more that some people need, right? I mean, there might be some of us who just the inherent value of something is enough to preserve it. Like, I'm totally behind that 100%. I feel like for some people, there might be something more, and maybe it is a more analytic understanding of what they're looking at. I could be wrong. I hope I'm wrong, but I have a sense that wonder only works for some folks, but not for everybody.
Do you know
Yeah,
when she said this quote? I'm really curious at what point in history we could peg it in this appetite for destruction concept that she's talking about.
Yeah, I don't know if this is like pre-Silent Spring or at the same time that she was publishing Silent Spring or sometime thereafter. It's a great question, but I'm really not sure. So, Sonalika, you were about to say something too.
No, I was just saying that that was like a wonderful point that you made. And I guess like what I was thinking was that even when we approach things from the point of view of maybe like pursuit of knowledge or pursuit of understanding and analytical understanding of something, even then there can be a differentiation between like the purpose for which we are doing it. um like, do we want to know what's uh say, like, I don't know, like, do we want to know what resources are present because we want to extract that and make a profit from it, or do we want to understand what's going on better? And I think there's like a difference there.
Yeah, yeah, I tend to agree with you. I think of like the tropical rainforest, right? So it would be great if we just preserved the tropical rainforest because of its inherent life-giving value, right? We also know that we could potentially be losing a cure for cancer, or who knows what type of utilitarian benefits from the loss of species, things that we just don't know about, what's going on there. So yeah, I don't know. I don't know. I'm conflicted a little bit by this. I have a sense that um, that for a lot of people it takes more than just wonder, but maybe not.
Yeah, I think it's almost a radical concept she's proposing as we've been talking through it. I think because so for me last week I visited 3 of our national parks here in the US, and those are a great but quite radical example of how preserving something exactly as it is and allowing people to just go experience it and the wonder that it provides encourages them to be more likely to protect the natural environment, maybe at home or maybe just supporting the national parks. But national parks is quite radical. The idea that you would take some of the most beautiful landscapes and you would like isolate them and make them difficult to reach so that people would have to work a little bit to get to them and could never extract the natural resources. I mean, it was quite a brave idea when we came up with it. So I think it's hard to think of good examples of when wonder alone can encourage us to not be utilitarian about a resource or something, because it's really hard to get human beings to stop viewing the world that way. We naturally do.
Yeah, I agree with you, Valerie. Good example. I think this is a radical idea. Um, and I guess I think I'm typically a cautious optimist, but I guess the critic in me is a little suspicious.
So Maggie commented that she said this quote in 1952, and I was curious just because I was wondering in the general framing of the 20th century whether this was before or after, how long after the nuclear bombs were dropped, since that really was a seminal moment in human history and destruction in particular. And so this was, a few years after that, but very likely something that she was thinking of as it was hard to be alive, I imagine, during that time and not have it inform your worldview.
Yes, agreed. Well, any final thoughts? All right. Well, thanks for that. That was fun. Appreciate that quotation, Ms. Carson. That moves us along to Astro 365, this day in the history of astronomy. And on this day in 1802, Heinrich Wilhelm Matthias Olbers discovered Pallas, the second asteroid ever to be discovered. And, this discovery kind of got me thinking about what I'm used to seeing in the media about asteroids. And I thought I'd take a moment to kind of dispel a little myth about how many asteroids are in the asteroid belt and what it would look like if you actually flew out to the asteroid belt, which is where Pallas is, and what you might actually see there. But why aren't those slides there? That's really interesting. That is not what I expected to see when I advanced that slide. Interesting. Perhaps they got moved. Oh yeah, they're down at the bottom. Don't know how that happened, but here they are. Okay, so here is Pallas, and this is a picture taken by the very large telescope array down in Chile. So it's actually multiple telescopes, optical telescopes with 8-meter mirrors that are all hooked up electronically to get this kind of resolution on this asteroid. To get an idea of how big it is, these are in order of discovery. So Pallas is number 2 relative to the moon in gray. And so the largest asteroid series on the left is number 1, and then Pallas is number 2, actually the third largest asteroid. Number 4 is Vesta, just larger than Pallas, number 2. So typically the images we see of asteroid belts, even this one from JPL, are something like this. You see this like ring of material of just like billions of little chunks of rock, and it looks like if you flew through there would just be rocks all around you. And if you think of like movies like Star Wars, which we'll talk about a little bit later, or all like the sci-fi movies you've ever seen, typically like when they fly through asteroid belts, or even in Star Trek, there's like chunks of rock everywhere, and they're having to like dodge left and right and up and down to get around them. This next slide shows you what you would actually see if you were in an asteroid belt, just any random place in an asteroid belt. You would see nothing because asteroid belts are mostly nothing. We are talking about huge, huge areas of space, right? An entire orbit around a star. Right? Think of how long it takes the Earth to go around the sun, an entire year, and the distance that Earth traces out through space during that time. This is a huge, huge circumference, right? That orbit. So the asteroid belt has maybe hundreds of thousands, maybe millions of chunks of rock. But over that vast distance, you would not see anything if you just plunked yourself down at a random spot in the asteroid belt. And these chunks of rock are small, right? Really small compared to the moon. So unless you actually ended up near one of those objects, you might see one of them. But the chances of actually seeing a second asteroid from any one place in the asteroid belt next to another is very, very low. So you would see a lot of empty space. And, one direction there'd be a star probably because you'd be orbiting around a star. But that's probably about it. So I thought I'd just like to mention that about asteroids for folks. Those of you who have this conception in your mind about asteroid belts. They're mostly empty space, kind of like solar systems, kind of like galaxies, kind of like the whole universe. And that's why we call it space and not stuff, because there's way more space out there than the stuff inside of it. All right, so let's go back and sorry, that's not where I wanted to go. I wanted to go back up to this discovery. So that was just over a couple hundred years ago. And the interesting thing about this is that as of 2006, Ceres was also classified as a dwarf planet. And so now Pallas might actually be the first asteroid discovered because Ceres was actually discovered the year before in 1801. And so maybe Pallas was the first asteroid to be discovered now that Ceres is a dwarf planet. Maybe still an asteroid as well. Lots of overlapping categories now out in space. But anyways, it is now time for the astronomy news trivia quiz. And so remember, we're just doing this as one big lightning round now. So as soon as you think you know the answer to one of the questions, Valerie or Sonalika, you can just shout it out and we will tally up all the correct answers at the end. Are you ready? All right, here we go. Question number 1. Which exosolar planet turns out not to have an atmosphere according to recent observations made by the telescope that we formerly know as the JWST. Which exosolar planet was that?
I actually know this one.
Okay.
It's TRAPPIST-1.
TRAPPIST-1 is the name of the star. Which planet?
Oh.
Yeah, even I remember the star, but not the
They're all
planet name.
I don't know if I know the letter. Let's see. How about B? I'll take a guess.
You're right. It is TRAPPIST-B. It is the closest one in. Yeah. And so, it's hard to see these little lines here, but this is a really, really tiny solar system compared to ours because it's not orbiting a G-type star like our sun. It's orbiting a little red dwarf. And so all the planets are much, much closer. Just 2 to 3 times farther away from the sun, their sun, as Jupiter's moons are from Jupiter. So a very compact solar system. You can see it down there way within the orbit of Mercury. Because that star is so small and so much fainter than the sun, there is a possibility that those stars are actually in the habitable zone of that star, TRAPPIST-1. We don't know yet. All we know now is that probably life does not exist on TRAPPIST-1b because the temperature is probably about 450 degrees Fahrenheit. So probably not much of an atmosphere on TRAPPIST-1b. But there are still 6 other possibilities. So we should find out some more about that in the upcoming years. Okay, so we're going to give that one to you. Valerie, you got that? So now we're all tied up 1-1. Here we go. Next question. Which helicopter on Mars is about to reach its 50th flight?
I have no idea about this one.
There's only one.
I know there's only one. I just can't remember the name of it.
What is that little helicopter called? Think of all the nice optimistic names that we give all those Mars landers. You've got Opportunity. You've got Curiosity.
I know Perseverance, but I don't think that's the name of the helicopter.
Perseverance is the name of the lander that then launched the helicopter. What is the name of that little bugger? There's a picture of it.
It's so cute.
Right there.
It's like a family selfie right there.
I know, right? Yeah, they really did a nice job with that, with Perseverance, giving it like a selfie cam. It is Ingenuity.
Indeed, it is.
Ingenuity. Indeed, yeah. So yeah, it was only supposed to do, I think, 8 flights. It's now on 48. So it is trucking, and it has shown no sign of stopping. So we'll probably get to 50 sometime soon. Here we go. Next question, still tied up 1-1. Which planet in our solar system might have had a volcanic eruption, sorry about the typo there, on it as recently as 1991? It is not the Earth. I'll just tell you that.
I was just say, I know this one.
More eruptions, I think, in the last year. It's not the Earth, but it is in our solar system. It's a planet.
I think I'm going to go with Venus.
You got it.
Oh, yeah, nice.
It is Venus. Yeah. So this is old data from the Magellan spacecraft that orbited around Venus, and a researcher just got curious and he started looking at the old data. And over on the right, you can see that it looks like there's some change in topography near this volcanic vent. And so the idea is that this might be a lava outflow that happened back in 1991. We don't really know for sure, but it certainly looks like there was a topographic change there. But we don't really know yet. But there are missions planned both with NASA and the ESA in the next decade for Venus. So hopefully we will find out sometime soon. All right, Sonalika takes the lead, 2-1. Here we go. What was found on asteroid that was sampled in 2018 by the Hayabusa 2 mission? This is not a trick question. Something you might expect to find, that we are hoping to find on asteroids, because we look to them for the origin of what?
Water?
You're on the right track. I believe there was ice found, but this was more exciting, more closely related to our search for life.
Something with carbon.
You're on the right track. Yeah, even more fundamental. So here's a picture of the surface. What was found was uracil, one of the 5 key bases of RNA and DNA. Yeah, so you may have heard of the theory of transpermia, this idea that life was deposited here on Earth from other sources, particularly potentially from comets and asteroids. And over the last few years, more and more evidence is building that it might actually be the case, that the molecules necessary for life actually did arrive via asteroids and comets. But we don't really know for sure. All right, moving on. Next question. Who recently released their new spacesuit design that is going to the moon in 2025?
This is not a trick question, right?
It's not a trick question. No, this is actually the company that just released their new spacesuit. They were contracted by NASA to design it.
Oh, okay, that's trickier. I was going to say NASA, but it is not. It's a deeper answer than that.
Deeper answer, yep. NASA contract with these guys. One of the big space technology companies you may have heard of in the news recently. They've done a bunch of stuff.
There's so many of them now.
This is Axiom. Here's their new suit.
Oh, nice.
The one that actually goes up to the moon is going to be white.
Okay.
With solar radiation, but they thought it was more fancy to do their prototype in black, which I think is pretty cool. But the cool thing is it has way more ability for dexterity than the previous spacesuits had. So in the demo that they did just last week, they had the engineer wearing the suit give a thumbs up, like no problem. And so, yeah, you can wiggle your fingers around and do all kinds of fun stuff in this spacesuit.
I feel like that looks like a suit you'd see someone wearing on the slopes of the mountains. Like, it doesn't look that much more sophisticated, which is a cool thing. It's getting better technology.
Yeah, the real cool addition is that lights are built in on top of the helmet. It's hard to see in this image, but there are a bunch of lights up there. Because presumably people are going to be walking around on the moon a lot, and it's dark up there when it's not daytime because there's no atmosphere. All right, still 2-1, I think. Sonalika, next question. An international team of scientists have developed what that can keep astronauts well nourished on future missions into deep space?
I do not know, but my brain is definitely in a certain mood today because the first thing that popped into my head was Soylent Green, and it's definitely not that.
No, we're not going to be liquefying people. I'll give you a hint. It was on the intro slot side for tonight's Astro Show. It was one of the 3 things that I had listed up there. I'll give you a hint. The astronauts are going to be really healthy because they're going to be eating a whole lot of what? Not ice cream, but
salad.
Salad.
Right. That's the only opposite of ice cream that I know.
No, I figured that would all be that you needed. It is space salad. So it turns out that kale, soybeans, carrots, and sesame seeds are really, really easy, or poppy seeds, excuse me, are really, really easy to grow in really, really small areas in zero gravity. So that's what these folks are going to be eating. They're going to be eating a lot of space salads, and you got the soybeans for protein and a little bit of roughage with the kale. So that is the deal. Lots and lots of space salad.
Probably pretty healthy. We could eat it more down here. It looks pretty good.
And kale salad is great. There was nothing in the article about any dressing, however, so it's going to be a dry kale salad. Anyways, we are now tied up 2-2. Here we go for the next question. To celebrate the 40th anniversary of Star Wars Return of the Jedi, Marvel Comics is releasing a set of one-shot comic books featuring fan favorite characters. The first to be released comes out tomorrow and features what famous desert gangster?
Jabba the Hutt.
Jabba the Hutt! Yeah. Nicely done, Sonalika. It is, in fact, Jabba the Hutt. All right. 3-2. Sonalika back in the lead. Here we go. Chinese probe Chang'e 5 recently returned to Earth with lunar samples that revealed blank trapped in minuscule beads of glass.
This is crazy. It's water.
That is water. Yeah.
I don't understand it at all, but it's awesome.
It is pretty cool. Yeah. So we knew that there was frozen water up on the moon. What water is doing in these little beads of volcanic glass, we don't know. Very cool stuff. But I did have some fun learning how to pronounce Chang'e. I didn't know that's how it was pronounced. It turns out that it's named after the Chinese moon goddess. There's a really interesting fairy tale about this woman flying out to the moon to protect her husband. And she became the moon goddess, and that's why the Chinese probe is named after her. And I'm still probably butchering it, but that is close to the correct pronunciation, I believe. Okay, we're tied up again, 3-3. And how many more questions do we have? I think we might just have a handful more. All right, here we go. Oh, there are the beads of glass, by the way. These little volcanic beads of glass with water in them. Pretty wild. Okay, here we go. A study published yesterday reports on the possible relationship between fast radio bursts, FRBs, and what?
Magnetars?
You are correct. Yeah. Specifically, gravitational waves from magnetars. So merging neutron stars. Right? So the idea is that fast radio bursts might actually be caused by gravitational waves. We're not totally sure yet, but there was a recent observation of gravity waves, and then from the same source a couple minutes later came a fast radio burst. So very likely that they are related somehow. Potentially the fast radio burst comes because of the gravitational wave, but we don't know yet. But yeah, merging neutron stars. Pretty wild things. All right, Sonalika takes the lead again, 4-3. Here we go. What was recently discovered in the central bulge of the Milky Way galaxy? It's not the supermassive black hole. We already knew that was there. This is something else.
I do not know.
Can I take a guess? Is it like traces of... I read there was a study about like traces of maybe collision with an older galaxy.
You're on the right track.
So maybe older stars, maybe?
If we're going to give it to you, it is older stars. It's actually the proto-galaxy that is believed to have formed the Milky Way. But I'm going to give it to you for older stars because these are all extremely metal-poor stars. These are the earliest stars that formed the Milky Way galaxy. Probably, stars that originated from the Big Bang. And astronomers had identified several hundred of them before. But using data from the Gaia mission and pretty amazing machine learning techniques, they have now teased out tens of thousands of these metal-poor stars that all hunker together in the very center of the bulge of the Milky Way galaxy. And so that white area in the center is believed to be the proto-galaxy that actually created the galactic disk that now most stars of the Milky Way belong to. So yeah, very, very cool stuff. Thanks to the Gaia mission and incredible machine learning techniques. It turns out that the spectrometer on the Gaia spacecraft wasn't good enough to actually get the metallicity of these stars. There was too much noise in the data. And so these astronomers had to create this new algorithm and trained a computer program to recognize better spectra of metal poor stars, and then fed the bad spectra back into that algorithm, and actually were able to identify some key markers to figure out that these stars were actually all metal poor stars. So they've done it now, I think, with 10 million of these stars. And I think the Gaia database is several tens of millions more. And so they are going to do it with the whole database now. And probably just find even more of these metal poor stars right in the core. All right. I think that brings Sonalika 2 points ahead. I think it's 5-3 now. All right. Here we go. What is now believed to be the largest space-based contributor to light pollution? We usually think of light pollution as coming from the ground. There are a couple space-based sources of light pollution. We used to think it was one. Now, latest research suggests that it's the other.
Satellites, is it?
Satellites was believed to have been the largest contributor. Turns out that satellites are only 1% of the total space-based light pollution. Turns out the other 11% is from something else. Very tiny.
Very tiny?
Mm-hmm.
That's not what I was thinking. I was thinking large.
Very, very tiny. And there are lots of them. Millions.
Space, like debris?
Space debris. Yeah. So it turns out, although very small for the most part, they do reflect a ton of sunlight. And so the current model is that 12% of sky glow is going to be contributed by space-based debris, reflecting sunlight back down. Of that 12%, 11% is believed to come from space debris and only 1% from satellites. Wild, right?
I actually didn't know that.
Yeah.
So this is new knowledge.
Yeah. I was thinking rocket bodies, which are space debris, but they're very large pieces of debris, and there's lots of tiny pieces that we put up there too.
Yeah, so there are big ones, right? So I can't remember the exact numbers that I read last night. Something like there are 6,000 pieces over a meter, and then it's something like 40,000 over a centimeter, and then like well over 1 million below a centimeter or below a millimeter, something like that. So yeah, they're mostly small pieces, but there are some large ones. So I'm sorry if I threw you off. I didn't mean to just distract you with that, but yeah, it's mostly small pieces of stuff.
It's like fog or dust. When you light it up, it's very hard to see through.
Yeah, there you go. Exactly. Good analogy. And this is not shown as scale here. These pieces of space debris are way, way larger than they actually are. Okay, we have one question left. Here we go. Despite claims that it might be an alien spacecraft, it turns out that what was just powered by escaping hydrogen gas?
Oh my gosh, I have not said the word in so long. I'm sure I'm going to say it wrong.
Yeah, it took me a while to say it as well. I had to remember, but I think you got it, Valerie.
I might not. Oh my gosh, I feel I need to Google it just to verify that I know how to say it. But my brain is telling me Oumuamua, but I think
Oumuamua, that's it. Yeah.
Close.
Yeah, so this was the interstellar rock that came through the solar system in 2017. And as it orbited around the sun and left the solar system in an open orbit, never to return, it started accelerating, which was really, really weird. And astronomers didn't really know how to explain it. And so quickly, there were all kinds of hypotheses that it was a disguised alien spacecraft, yada, yada. A couple of astronomers now have figured out that there is a model for comets that get exposed to cosmic rays for long periods of time, as this object would have, having come from outside of the heliosphere. That basically these cosmic rays can penetrate deep into the comet and ionizing hydrogen, which then gets released when the object gets close to a star. So it was close enough to have released that hydrogen, but there wasn't enough hydrogen to be visible as a tail, which was not observed. Right, so that's why all the alien hypotheses came up, because it didn't look like a comet. There was no noticeable tail. It was probably just venting hydrogen gas, and that's what caused its acceleration as it left the solar system. So, sorry, Oumuamua, we won't see you again, but safe travels, and we know you're just a rock. All right. Well, that concludes the astronomy news trivia game, and Sonalika is our winner, 5-4 this week. Nice job, Sonalika. All right. Oh, I forgot. These were the images that got put in the wrong place. Let me get down.
Paulus. Good to see you again.
Yes. Okay, so one more segment, and then we're going to let Sonalika tell us all about her research. It's What's Up, Dr. Sam? Two cool things going on. If you haven't already heard about this, there's a planetary conjunction tonight. It's been getting better and better over the last several nights. And last night and tonight, it's really good. You could potentially see 5 planets. Only 4 of them are shown here. Jupiter, Mercury, Uranus, and Venus. Mars is a little higher up in the sky. But you can potentially see 5 planets. It turns out that Uranus really is just barely visible to the naked eye from a really, really dark location. So forget about seeing Uranus from any type of even like small city. You need to be out in the boonies to be able to see Uranus, but it's possible. But look right after sunset to the west. You should be able to see Jupiter and Mercury right on the horizon after the sun sets. Farther up to the west, you should see Venus, no problem. Maybe if you're lucky, you can spot Uranus and Mars farther up in the sky. A lovely little red dot up there to the southwest. And last week turns out to have been the best week to do a Messier marathon. You can still do it this week from some southerly latitudes. If you're not familiar with this, this is the 1 or 2 weeks of the year where you can actually see all 110 Messier objects on one night. For those of you who don't know, Charles Messier was a French astronomer, late 1700s, early 1800s, who was a really good comet hunter. And I think is credited with discovering 11 comets. And he kept meticulous notes of all the fuzzy things that he saw in the sky that didn't move with respect to the background stars night to night. So those objects weren't comets. He would be rolling over in his grave if he knew that we knew him for all the objects that turned out not to be comets, as opposed to the 11 comets that he did discover, but that's what he's known for. The Messier objects are 110 of the brightest fuzzy spots in the night sky that are up there throughout the year. Galaxies, nebulae, star clusters, globular clusters. And throughout the year, you can only see some of them, because some of them are below the horizon when it's nighttime. But every spring, from about, I think, 9 degrees above the equator up to about 30 or 35 degrees north, you can actually see all 110 on one night. So it's called the Messier Marathon. And I've never done it myself. I've only seen, I think, maybe about 60 or 70 of them in one night, but you could do a whole 110 apparently this week, maybe with the exception of M30. That's the hard one. But good luck if you'd like to pull out a last-ditch effort to do a Messier Marathon, but if you missed it this year, no big deal. You can do it again next year. This year was particularly good, though, because it fell on a new moon, which helps to get those fainter Messier objects. But anyways, that's what's up. Have fun seeing the planets tonight. And with that, Sonalika, again, thank you so much for joining us. And I would love for you to tell us just a little bit about how you got into astronomy and what you study these days.
Hi. So how I got into astronomy was, I think, pretty random. I was always interested in science and maths. So I took up physics for my bachelor's, and then I did a few projects. I think one of the projects that I did was about detecting dark matter, which was like high energy astrophysics. But then I think I explored a bit more and I found out about JMRT in the Giant Meter Wave Radio Telescope, which is run by our institute in India. And I think it's like one of the most sensitive telescopes in this wavelength range. And I was just amused by like indigenous instruments doing such good work. And yeah, so I was impressed by that and applied for this institute, and here I am.
Nice. So were you into astronomy as a kid?
Not really. I think I went to a planetarium once or twice, which was really fun. Um, I think there's a city in India, Kolkata, which has like a um, park, like a science park sort of thing, where I went once, and I think that kind of made a big impression on me. Um, but other than that, I think like telescopes and such things weren't very accessible where I was growing up. But yeah, visiting planetariums was like amazing.
Nice. Very cool. So what do you study now?
So right now, what I'm working on are these galaxies called green pea galaxies, which have like very interesting names. And these galaxies were actually discovered by citizen scientists in the Galaxy Zoo project, which is run on images from the STSs. And so a lot of people noticed that they were seeing this sort of green blobs in the images. So these are actually galaxies that are so tiny that they are unresolved by STSs. So they look like round peas. And the green color in them actually comes from very strong O3 lines,
Hmm.
so oxygen lines. Um, and at the redshift at which they are seen, these lines look green to us. Um, and that's how they got to be named as green pea galaxies. And yeah, so these are one of the main reasons why these are of like a lot of interest to us right now, is that these galaxies have properties which are very similar to like the galaxies found in the very early universe during a period we call the epoch of reionization, when like mostly dwarf galaxies kind of reionize the neutral hydrogen in the intergalactic medium. And so those early galaxies are of course very hard to observe directly because they are like tiny and very far away. And so galaxies like the green pea galaxies are like very important proxies to understand what was going on at
Hmm.
that time. And I specifically use radio telescopes to look at the gas in these galaxies. I use the H121 centimeter line um, to detect neutral hydrogen. And that helps us kind of compare the stellar properties and the gas properties and understand how. So, uh, I'm very sorry. I think there's a light out in, in
No,
at my
Very,
house.
we
there's
can
a sudden
see you.
atmosphere.
Yeah, it just looks like you're
Yeah,
out in space now. It's
we
great.
lost electricity.
It's okay. We can still see you and hear you loud and clear.
Yeah, so I'll just continue. So I one of the interesting properties in green peas is also that they are starburst galaxies. So they are forming stars at rates that are like up to 100 times what we see in normal galaxies like our Milky Ways. And another thing that we observe is these galaxies also leak ionizing radiation, such as like the Lyman alpha. Okay, the light is back. So Lyman alpha and Lyman continuum emissions, which would generally ionize the hydrogen gas in the intergalactic medium. So it's like a curious thing that we observe both of these things simultaneously in some of green peas. Like we see a large amount of hydrogen gas, neutral hydrogen gas, and we are seeing that these galaxies are leaking Lyman alpha emission. And to understand how both of these are simultaneously happening, like how the fueling of the star formation through the gas is being balanced by the it's kind of and the leaking of Lyman continuum emission, which requires low column densities of hydrogen gas, how these two are kind of balanced is like an important kind of open question. And we map the gas using radio telescopes, radio interferometers, such as the GMRT and VLA, to understand what's going on.
Very cool. So, what is your hypothesis? Why do you think you're seeing both of those different emission lines?
So our hypothesis, which we have verified so far in one galaxy, is that a lot of these galaxies are kind of in interaction with maybe companions, um, maybe currently or maybe in the past, which gives them kind of irregular kinematics to the gas. So we what we suspect is like um, either like the gas that is fueling the star formation might be coming from a companion galaxy or from a merger event, and within the galaxy there might be like kind of holes or columns of low density gas within the otherwise um, maybe relatively higher amount of gas, from which like these holes that comes from the disturbed gas distribution from the merger events, that the Lyman ionizing Lyman alpha and Lyman continuum emission might be leaking.
Hmm. Very
I
cool.
hope that makes sense.
Yeah, I mean it's complicated stuff, but it's really cool. So, I mean, I assume that these might be questions that the James Webb Space Telescope might be able to help out with. Is that something that you're considering?
Absolutely. So I am working in radio, but like I do have like I know of people who are looking forward to working on that. So that would be interesting too, because we'll get to know, actually observe and know more about the um, galaxies during the epoch of reionization, the early galaxies, and we can compare those with the nearby galaxies with similar properties. Caveat is still that even though we'll be able to observe the optical and infrared from JWST, uh, radio observations at those redshifts are still very difficult. So we still need like low redshift kind of analogs of those galaxies to look at the gas properties.
Right. Yeah, that makes sense.
Yeah.
Very cool. So, you're working on your PhD now, is that right?
Yeah.
So are you thinking you're gonna stay in the same field of astronomy after you finish up? Or are you already thinking about other lines of research? Where are you at with that?
That is a tough question to answer. I think um, I am not very keen on continuing in academia as such.
Hmm.
I have been exploring options of maybe doing something in science communication or science education research, but these are things I'm still exploring and I'm not very sure where I will go.
So you're preaching to the choir here about science communication. That's what we do. You're in good company. Yeah, after my PhD, I didn't really want to stay in academia either.
Yeah.
Well, one of the questions that we like to ask all of our special guests is, what's the one question that nobody ever asks you, but you wish people always would?
I think for me, one of those questions is so, for example, whenever we we have a conversation about being in astronomy with people, one of the first questions people usually ask is like, how did you get into it? And like, what got you interested in it? Which makes a lot of sense. I mean, that's an important question to ask and wonder about. Um, a question I wish people would ask more is, especially to people like PhD students and grad students and students within the academic system, is like, have you ever felt like, did you ever feel like leaving,
Hmm.
and what made you feel that?
Hmm.
Because I think that question has the potential to address a lot of structural and institutional kind of loopholes
Hmm.
or spaces that we could work on to provide better support to students.
Yeah, that's fantastic. Thank you for mentioning that. And if you don't mind me asking, have you ever thought of leaving, and why?
Oh, I've already decided to leave.
So yes.
Yeah. I think one of the reasons is like I just don't see myself enjoying this environment a lot. I think I enjoy like exploring science in a broader way rather than, specializing in a very, very specific area. I think that kind of bores me a little bit. Um, and other than that, I think some of the things that have played a factor in this has been like a bit of like definitely lack of diversity and lack of support a little bit. Especially in India, like as a queer person, like it's still hard to like I started my PhD in 2017, and being queer was like a criminal offense till 2018. So
Um,
we have a long way to go in terms of providing support for gay people. Yeah, so I think that, yeah.
well, thank you for sharing. We really appreciate that, and yeah, I mean, good on you for sticking with it all these years. That's pretty amazing. And,
Astronomy is fun.
it's fun. Yeah, it's a lot of fun. You know, there are lots of ways to be involved with science, like you were saying.
That's true.
And science communication is definitely the path that I chose, and I love
Yeah.
it. I did a little research back in the day when I was an undergraduate student, but and then I obviously had to do some for my PhD as well. But after that, I I just really had no interest in doing that. I love teaching people
Yeah.
about the sky and astronomy, and that's how I like to be involved with science as an educator.
Yeah. And I think that diversity of involvement is very important.
Yeah, I mean, there got to be some people who do the research, and there have to be folks who communicate it.
Yeah. And thank you for
Yeah,
doing that.
Yeah,
yeah,
well,
because they're often very different personalities.
Yeah, indeed. Yeah, I mean, and you do a really nice job in describing the research that you're doing, right? And that is a talent in itself. So, nice work with that.
Thank you.
Yeah.
Today was so exciting. I learned about space kale and space peas. It was not at all what I was expecting to take away from today. It's just great. And that's the fun part about being in science communication, is that you get to make that be the story. You know, you get to take the interesting research and figure out ways to get other people as excited as you are, because what I hear is that you have a deep passion for the subject and to endure the more difficult aspects of getting the PhD. So good for you. And I hope your enthusiasm sticks with you, because you'll be a great communicator if you're that enthusiastic about it.
Thank you so much.
Yeah. Well, Sonalika, we're just about out of time. I always like to give the last word to the special guests, and so if you have any words of wisdom or ideas that you'd like to leave us with, or to send out there to other people potentially interested in studying astronomy or science communication, feel free to offer those ideas.
I think I'm going to steal from Rachel Carson here and tell people to just follow their wonder, experiment with things, try out things as much as you can, try out different fields, try out different ways of engaging with your interests, and follow your wonder.
That is beautiful. That is a wonderful thing to steal. I'm sure Rachel Carson would approve of that. And in education, we like to say borrow. You can always borrow the ideas of other great educators. So, nicely done with that. I think you're already a wonderful science communicator and educator and eloquent speaker about all things astronomy. So we'll look forward to seeing your name in future science communication articles, and maybe on the Astro Show again sometime.
That I would love that. Thank you so much.
Yeah, well, it's been a pleasure having you this evening. Thanks so much for joining us. We've got a thank you gift for you, and Maggie will connect with you on that. So thanks again for your time and your words of wisdom. We really appreciate it.
Thank you for having me. It was a lot of fun.
Yeah. And Valerie, as always, thank you for joining us. We wouldn't be here without our co-stars, and so thanks for holding down the co-star fort tonight, Valerie. I'm excited to have you. And thanks to everyone behind the scenes, Wyoming Stargazing Board of Directors, Maggie, our Operations Director, and everybody else that makes the Astro Show possible, including all of you out there who are watching live and who will watch the recording of this sometime later on. We really appreciate you tuning in, and thanks for joining us. We'll see you next week, next time in a couple weeks. But until then, be well, and don't forget to look up. We'll see you then. Bye.